Okay, here's warm-up 7.5. Anytime we're working with these rational expressions, it's probably a good idea to do any factoring you can before you add or subtract or multiply or divide. So looking at this first problem, I can't actually do any factoring. That's not a difference of squares up there. There's no common factor. So I can't do any factoring. So then I'm thinking, okay, I'm adding two fractions together. Well, I'm going to need a common denominator. So I'm looking at the denominators, 6 and 12. Well, hey, if I just double this denominator, then I'll have the same denominator. And as long as I do the same thing to the numerator, then I'm really just multiplying this by 1. Not changing its value, just changing its form. Okay, so let's see. Leaving the first fraction alone for now. But then I've got 2x over 12. Okay, now let's add this all together. So combine it into one fraction. I'm going to put the 2x in front of the negative 2 to put it in standard form. Okay, so I've got it down to this. But now what I'd want to check is to see again if I can, maybe I can factor the numerator. It actually wouldn't lead to any canceling even if I could. But it turns out this one's not factorable anyways. There's no two numbers, no two integers at least, that multiply to negative 2 and add to positive 2. So it'd have to be 1 and negative 2, that's not working, or negative 1 and positive 2. So that's a dead end. So here we go. That's my simplified version there. This says solve, but it really should say simplify. All of these should say simplify. I'll fix that. We can't solve for x because these aren't equations. I think that was just a typo. Okay, so next up, let's do some factoring again. The only thing I can factor here is this denominator. It's a difference of squares, right? Because n times n is n squared, 4 times 4 is 16, and I'm subtracting, that makes it a difference. So this is going to factor into n plus 4 times n minus 4. And that makes it a lot easier to work with the problem because now when I'm looking at the denominators, I can see they have something in common. They both have n plus 4. So the one on the left's just missing the n minus 4. So let's multiply by n minus 4. Okay, and on top I'm just going to do this so it doesn't look like I'm subtracting 2. I'm doing n minus 4 times that. Okay, all right, so let's start cleaning up the numerator a little bit on this first one. So yeah, we can distribute here, negative 2n plus 8. Okay, this is my whole first, that's the first numerator, right? The second numerator is just going to be n squared. I'm going to combine these into one fraction. Okay, and then I just use the same denominator, right, when I combine these. Okay, so then again, let's start cleaning this up. So I'm going to put negative n squared in front. Okay, and then I always like to factor everything. The denominator's already factored. Let's see if we can factor the top to see if maybe I can do some more reducing. Okay, so whenever I have a negative squared term with a trinomial, I like to factor that negative out. It just makes it easier to factor the remaining trinomial. So then looking at this trinomial, let's see. I've got, here I'll put 2 up there and a negative 8. So let's see. If I did 4 and negative 2, then I've got a winning pair there, right? So yeah, I ran out of space. So well, I'll just keep working this way. Okay, so I've got my negative out there still. This is going to factor into n plus 4 times n minus 2 all over n minus 4 times n plus 4. And now I can see that there is some reducing that I can do, right? And don't forget about the negative out here. So when you'd probably multiply that, you could leave it, I suppose, factored out. But if I distributed it back in, it would look like this. Okay. And then I also need to give a shout out to n plus 4 over here that got canceled out, because if I plugged in a negative 4 for n, that would give me a 0 denominator. So I want to list that as an undefined x value. and can't equal negative 4. I don't need to list positive 4 because I can see in the simplified version here, yeah, and can't equal positive 4 here, right? So only list the ones that you wouldn't be able to tell just looking at this final simplified fraction. That would give you a zero denominator somewhere further back in the question. Okay, so there's that one. All right, maybe I'll do this to separate it. Okay, let's try one more here. So looking for factoring. I can't factor the numerator there, no common factor. That's not a difference of squares, but I can factor this. So let's go ahead and do that. Okay, so 3 and negative 6 is my winning combo there. Okay, and now that it's factored, I can see what the denominators have in common, so that means I can just multiply this by x plus 3 over x plus 3. Another way to handle this, if you didn't factor this at the beginning, you could multiply the left fraction by x minus 6 over x minus 6, and the right fraction by the trinomial over the trinomial. It's just, it will be a big mess, and it's a lot simpler if you can find some common pieces in the denominators. Okay, all right, so I can see what my common denominator is. I'm going to have to FOIL this, right, together to start cleaning it up. So my first numerator is 3x squared minus 1. My second one is going to be the FOILage here, so x squared plus 3x plus 2x. So x squared plus 3x plus 2x would be 5x. And then 2 times 3 for the last is 6. Okay, and I've got that all over my common denominator. Okay, and now I'm going to start cleaning this up. So let's distribute the negative. Okay, I'll combine like terms now. So let's see, 3x squared and negative x squared would be 2x squared. And then I've got a negative 5x, and negative 1 and negative 6 is negative 7. Okay, and I still want to check the numerator. I've got that trinomial, and it seems like, hey, that looks like it might be factorable. So going to do a little side problem here. Okay, I'm going to do a modified diamond problem. I'm going to pull the 2 out and multiply it by the negative 7. Like so. And then I would factor this with a diamond problem. So I'm looking for 2 numbers that multiply to negative 14 and add to negative 5. Well, how about 2 and negative 7? So that's going to factor like that. And then, since in the beginning I multiplied by 2, now I divide the number parts by 2. Okay, and I've got x plus 1. Since I can't reduce 7/2, I pull the 2 out in front of the x, and the 7 falls to the ground. Okay, so the top of this, it turns out you could actually leave this like this because it's not going to reduce anymore. When you do factor the numerator, you get this, but there's still no reducing to do. So, you know, these are equivalent. Doesn't matter which one. I like to just always factor everything so you can see that there's no more reducing to do. But I suppose you could even multiply the denominator together as well if you'd rather write that as a trinomial. But I like to leave it factored. That's it, and I'll see you next time.